looking at counting principles. We talked about the basic counting principle. We looked at permutation of an entire set of objects. Then we talked about NCR. Now we want to look at NPR. Now, NPR allows us to find the number of ways you can select R objects out of indistinct objects without replacement and then arrange them in a sequence. So if we go back, how is this different from NCR? If we go back, NCR is a number of ways you can select R objects out of N objects without replacement. So NCR is only when you're doing selections. NPR is when you're doing selections plus arrangement. Right, so NPR is selection plus arrangement, NCR is just selection. Now the formula for NPR is NCR into R factorial. And you know NCR, we looked at earlier, is N factorial divided by N minus R factorial into R factorial. So when you multiply this with R factorial to get NPR, it leaves behind N factorial by N minus R factorial as here, right? So NPR is just NCR into R factorial. So the difference between NC and NPR is NCR is only for selection, NPR is for selection plus arrangement. Let's look at an example. Find the number of possible 10 character passwords when all the 10 characters have to be letters. So for each of the 10 characters, we have 26 options because we have 26 letters. Right, here we'll apply the counting principle to find the total number of possible 10 character passwords because the first can be done in 10 ways, the second in 10 ways, the third in 10 ways, and so on. So by the basic counting principle, we know together they can be done into 26 into 26, whether we are multiplying 26 10 times, which can be written as 26 to the power 10. Now we cannot apply NPR here as NPR requires without replacement. And here there's no restriction that you cannot repeat the letters, right? You can reuse the same letter. Like it's not saying that the 10 characters have to be letters and distinct. So there's no such condition that, you cannot repeat the letters, right? So you can think about it as selecting 10 letters from 26 letters with replacement. So you can't apply NPR because like we said, NPR requires without replacement. But if the question was that you need to form a 10 character password such that all letters must be distinct, then here you can use NPR 26P10 because you can because in this case you can think about it as selecting 10 letters out of 26 letters without replacement to arrange them. Right? So here you can use NPR. Earlier you could not use it because here it's like selecting 10 letters out of 26 letters with replacement. But here, when we specify that the letters must be distinct, so you're selecting 10 letters out of 26 letters without replacement to arrange them. Because once you use one letter, then it's like you're not replacing it and you cannot reuse the same letter. So key takeaway from this example is that if you want to select R objects out of n distinct objects with replacement, like in part A, and then arrange them in a sequence, we use counting principle, n power R, right? Because the first object can be done in n ways, the second can be done in n ways, so on. And like each of the R objects can be done in n ways. So together they can be done in n being multiplied R times, which is the same as n power R. So NPR won't work in this case as NPR requires without replacement. So the key over here is, if we go back to summarize, we use NCR if we want to select R objects out of n distinct objects without replacement. So NCR is used for selections without replacement. We use NPR if we want to select R objects out of n distinct objects without replacement, and then we want to arrange them as well in a sequence. So NCR is for selection without replacement, NPR is for selection without replacement plus arrangement. So you want to do one additional thing. After selecting them, you want to arrange them. If now you use the counting principle, if you want to find the permutations of the entire set of n objects, you want to arrange that entire set of n objects, you use the counting principle like we learned, they're n factorial. Or obviously, if there are repetitions in them, you just divide by the repetition. So you can account for that, right? So use counting principle if you want to find arrangements of the entire set of n objects, where if all those n objects are distinct as n factorial, if there's some repetitions in them, then we know we just eliminate the repetitions by dividing by them, by dividing by the possible arrangements. Or you also use the counting principle if you want to select R objects out of n distinct objects with replacement and arrange them in a sequence, like we did in that examples part A n power R. Right, so you use the counting principle if you want to either find the arrangements for the entire set of n objects, or out of n distinct objects, you want to select R objects, and you're selecting them with replacement and then arranging them. If this was without replacement, then we would use NPR. If it's with replacement, use the counting principle n power R. And here, this n factorial is only if the entire set of n objects is distinct. If they were not distinct, then we can account for their repetitions as well. We already learned that by dividing by their permutations, right? We already did that. That's the first thing we actually looked at here. It, here we looked at it. Right, with n distinct objects, the number of permutations of the n objects is n factorial. And if some objects are indistinct, then we eliminate double counting.